Hi everyone. In this video we will learn about stoichiometry. Stoichiometry is uh, I should say the most challenging concept of chemistry in terms of moles. We learned about moles in the beginning of this unit, and this is the height of that mole and gram relationship. So this is the hardest it is going to get. Uh, but I mean, there are easy ways to do it as well. So I'll teach you both ways. I will maybe I will make two different videos to teach the two different methods, and then you can choose whichever method you like. It just matters that how comfortable you are with the dimensional analysis and with the mole mass concept. That's all the stoichiometry is about. So stoichiometry is the quantitative relationship of a chemical reaction. Like let's say you see a chemical reaction that iron reacts with oxygen to produce iron 3 oxide. So when I balance this equation, I have 4 moles of iron, 3 moles of oxygen, and 2 moles of iron 3 oxide. So the question when I look at this, it tells me that I need 4 moles of this, 3 moles of this to get 2 moles of this. But if I only have 1.5 moles of this instead of 4, then I can figure out how much of this I can calculate. I mean, I can produce. So that's all it is about. That with 4 moles, it is giving me 2 moles. Okay. If I, instead of 4, only use 1.5 moles, or maybe let's not give you a whole number, maybe 3 moles, maybe 27.8 moles, then how much of this I can produce? How many moles of this can I produce? So that's all the stoichiometry is about. The concept is not hard at all. If you understand that what is a chemical reaction, and the coefficients represents moles and what these are the molar ratios, then for every 4 moles of iron, you're getting 2 moles of this, 2 moles of iron is using 3 moles of, so it just depends how you're reading it. That's all the stoichiometry is about. And it just gives you another conversion factor. Okay. Let's say we want to do this. Example number 1. Determine how many moles of carbon dioxide can be produced. How many moles of carbon dioxide can be produced um, from the combustion of 1 mole of uh, propane. So if I write first of all, I need to write the equation of propane. Hold on, I don't know where is this coming from. I think I'm putting my fingers on too many spaces. Okay, so let's say first of all, write the combustion of propane. Okay, for combustion of propane, you're going to take, what am I doing? All right, I'm not even doing anything, it's writing. I'll move it. Okay. That's interesting. I'm not even touching it. Okay, let's try again. All right. So first of all, write a balanced equation of combustion. So let's use another space. I have uh, I have C3H8, and I want to write a combustion reaction. So combustion means I'm going to react with oxygen, and it has to produce carbon dioxide and water. So this is the information that you learned from the last unit. Okay, now I have 3 carbon atoms, so I have 3 carbon atoms and 8, and I put 4 here, so it gives me 10, so I put 5 here. So this is my balanced equation. Let's see what the question says. That what are the, okay, this is the question was right here. So I see that 1 mole of propane is using 5 moles of oxygen to give me 4 moles of water and 3 moles of carbon dioxide. Okay, and now I'm going to use dimensional analysis that, where is the question? That if I have 10 moles of propane, then how many moles of carbon dioxide can I get? Okay, if the question is that instead of 1 mole, if I have 10 moles of propane, 10 moles of this, then how much of a carbon dioxide can I produce? So I draw the dimensional analysis. I have 10 moles of propane, okay, 10 moles of C3H8. Now I apply the molar ratio. I see that 1 mole of C3H8, 1 mole of C3H8 is producing 3 moles of carbon dioxide. That's it. So moles of C3H8 get cancelled. You multiply it. That means I can get 30 moles of carbon dioxide. If instead of 1 I have 10. So that's all this stoichiometry is about. So we will do this at classwork on page 359, question number 9 and 10. Next, we now have three conversion factors to use in our dimensional analysis. We learned about that 1 mole is equal to the molar mass, which we get from the periodic table. We learned that 1 mole is equal to the Avogadro's number when it comes to, something is going on here. 1 mole is equal, hold on 1 second. Okay, so I'm going to try again. That 1 mole is equal to, what's wrong with it? 1 mole is equal to 6.02 times 10 to the 23 atoms, molecules, and formula units. And now the other conversion factor, the third conversion factor we are adding is the uh, mole ratio from the equation. You know that 1 mole is producing this and 2 moles is producing that. So we are going to apply the molar ratio from the balanced chemical equation. So first of all, you need to have a balanced chemical equation before you can apply the molar ratio. We will be using grams. So 1 mole is equal to this many grams, comes from the periodic table. 1 mole equals to Avogadro's number. 1 mole is equal to or molar ratio from the equation. So let's try an example. So I have sodium that reacts to chlorine to produce sodium chloride. This is a synthesis reaction, if you remember correctly. So synthesis means you're yielding this. This gas means solid, if you remember again. This means gas, okay, solid. All right, that's what it means. So 2 moles is combining with 1 mole, okay, to yield 2 moles of this. But if instead of 1 mole, I have 1.25 moles of chlorine. Instead of 1, I have 1.25 moles of chlorine. Then how many grams of NaCl can I produce? Well, 1.25 moles of chlorine. I know that 1 mole of chlorine is producing 2 moles of NaCl. Okay, that is a molar ratio that I'm getting, you know, this right from the equation. That 1 mole of chlorine is yielding 2 moles of NaCl. And then I know that 1 mole of NaCl is equal to this many grams of NaCl. This I get from the periodic table. And that's it. That's all the stoichiometry is about. That you apply the molar ratio and the rest of the story is the same. You know, that 1 mole of this is equal to mole of grams. The rest of the story is the same. I'm only adding this middle step in this. And this step is coming from the balanced equation. I'm adding the molar ratio. Okay, so again, we will do the practice in the class. So let's say let me change the question. Let me give you something else. I have H2 plus O2 to yield 2H2O, and I have 2H2. So the question is that how many grams of water can you produce if you have 38.5 grams of oxygen, or maybe let's do moles of hydrogen. 38.5 moles of hydrogen. Okay, so what am I given? My given comes here. Okay, I'm given 38.5 moles of hydrogen. Now I apply the molar ratio. That 2 moles of hydrogen is yielding 2 moles of water. All right. So then, how many grams of water it is saying? And I know that 1 mole of water is 18.02 grams of water. And where did I get this from? The periodic table. So moles of water gets cancelled, moles of hydrogen gets cancelled. You multiply the 3 numbers and you divide by this. And that is your answer. That's all the stoichiometry is about. This is the hardest this concept is going to get. Okay, so we will do the practice in the class. Maybe I will do the limiting reactant in a separate video.